Welcome everybody. It is 2 o'clock Swedish time right now, so time for a new webinar from Flasheye. But let's give a couple of minutes for our guest to arrive, and we will start just in a moment. All right, I think we can start. Once again, welcome everybody on our webinar, Crash Course in Lidar Technology and 10 applications on how to achieve autonomy, safety and quality with LiDARs, of course. My name is Dariusz Komiak and I'm working at Flasheye as a LiDAR expert, customer support and running some R&D projects as well. And this course, this webinar will be fairly basic on LiDAR technology, and we will give you a couple of ideas where the LiDARs can be used. And of course, those are just suggestions, some starting points which you need to, which you can consider. And of course, you will have much more applications in front of you, I believe, while we will be going through this webinar. And this is a short agenda for today. I will start a couple of words about Flasheye and then move on a bit about LiDAR and technology overview to have same level of understanding what is actually LiDAR and a couple of quite important parameters to consider when we are thinking about LiDARs. And then moving on why it is crucial for innovating industries, and following up with 10 LiDAR applications. At the end, I will answer your questions, so feel free to ask those questions during the webinar in the chat, so I will get them, get summary of those questions from my colleague and then we'll answer them at the end of the presentation. So about Flasheye. We are a Swedish company originating from with our headquarters in Luleå, but our founder is actually from Kiruna. So you can imagine harsh conditions, a lot of industry, a lot of mining industry, which is quite heavy and difficult. And our founder at the time was working with many projects, had contact with many people in different industries, in different situations, and he found out a gap which needs to be addressed, and this is how a Flasheye came alive. The idea about Lidar processing software, which was not really there at the time, became true in 2021 when all work start to come together, and right now we have really well working software, which you will see a couple of recordings today, but mainly I would like to focus today much time on applications and why actually Lidar, what is benefit of using Lidar itself. So starting about talking about Lidar technology, just as a intuitive thing to understand, you can compare it to how, let's say, dolphins recognize where the other fish is in the sea by emitting signals and getting the reflection of this signal back. Though LiDAR, it is doing such a thing with light and measures time which light needs to actually get bounced from the objects. And we like to say to measure is to know, because if you measure, you know exactly. There is no guessing around. A little bit more into the LiDAR technology and LiDAR itself. LiDAR is an acronym for light detection and ranging, and LiDAR unit, LiDAR sensor, consists of three major things. First, which is transmitter, usually it is infrared laser diode. Then it is receiver, which gets the bounced reflection of the light which was emitted before. And the third one is actually a very accurate timer which measures the time between transmitter transmits the signal and receiver gets the reflection back. And based on knowledge what is the speed of light in the atmosphere and knowledge how much time it takes to get this reflection back, LiDARs calculate what is the distance to that particular point. Sometimes you will get LiDARs called like 3D laser scanning, and applications nowadays are very wild, from terrestrial airborne to mobile applications. Some of you might even have small LiDAR embedded in your phone right now. And a couple of types of the LiDAR sensors, starting with the simplest one, which is basically a single beam LiDAR. There is a transmitter and receiver, as you can see on this optics, and measure the distance to the wall, to the point. And this kind of LiDAR is traditionally used in those digital distance meters. If you have a construction or if you are working something out at your home, you might have one already. Basically very accurate meter which gives you distance between itself and the closest wall. And then moving up with more advanced LiDAR, it is a two-dimensional LiDAR, and what is the difference is that kind of distance meter what you had before, you are putting it on a spinning rotating platform, and then you know exactly at which angle measurement was taken, and based on that you know the distance to the closest point, you know the angle where this distance was measured, which means you are getting plane measurements. And this one is nowadays quite popular in robotic vacuum cleaners. Now we're moving to the three-dimensional LiDARs, which again, it is like based on previous technology, where you have moving parts which are moving very accurately, so you know where the measurement is taken and you are taking measurement of the distance. But in this case, you are doing it with multiple beams, multiple transmitters and or receivers at the same time. So you can capture three-dimensional objects, three-dimensional movement, and so on. And you might wonder, is there anything else can be done? And yes, there is a new technology which is called 4D LiDAR. And in this particular case, it is a new kind of technology, new type of the LiDAR, which is based on frequency modulated continuous wave, which means until now we had basically LiDARs which were sending basically the same signal every time and just measure the time until this signal will get back to the LiDAR. With frequency modulated LiDARs, the light and the wave of the light is continuously changing, and the LiDAR is doing a lot of analysis of this waveform, which is getting back to the LiDAR. And based on that, based on the Doppler effect and so on, you can get fourth dimension, which in this case is instant velocity, basically per point. So you can you can get directly out of the sensor velocities of the objects around you, and a couple of other features like even better range, because the signal received by the LiDAR does not need to be that strong compared to the traditional time of flight LiDARs. It might be much weaker return, but since it is frequency modulated, the algorithms will understand that that was a light, that was a beam, that was a wave which was sent much time before, and you can get much better and more accurate readings. Couple of crucial parameters for the LiDARs, which we are always talking about, and this is also good to understand and have in mind when you are thinking about applications. It is different kinds of field of view, and as you could notice on the pictures, I had different LiDARs. And what is a difference? In this case, and what I want to talk about now is difference between horizontal and vertical field of view, where in horizontal you have basically two options: either LiDARs which are spinning internally and giving you 360 degrees field of view in horizontal plane, or non-rotating sensors which are giving you fixed field of view. Basically, you can think about it as a camera. You have some kind of limited field of view, and then based on structure in itself, you will have different horizontal and vertical, and either wider or narrower, and so on. And vertical, in case of rotating sensors, this will be mainly limited by design and by number of beams which are inside the LiDAR. So you can have different configuration. 4, 8, 16, 128 is mostly common used higher resolution and with pretty good vertical coverage. And with non-rotating sensors, as I said before, it is very sensor specific. It is based on the technology sensor is using and optics and so on. But those are two main differences. And number of channels and resolution, those are another parameters which are extremely important in the LiDAR world. In rotating sensors, resolution is based on the vertical field of view and number of channels. So for example, if you have a sensor which has 16 channels, and this is like channels. Also, sometimes I'm using channels or beams, basically 16 lasers inside. And the field of view, vertical field of view, for example, 45, it will be fairly low resolution sensor, but when you have same field of view but 128 beams, it will give you much more information, and it will be much higher resolution, which means with higher number of beams you will get higher resolution, or with lower vertical field of view, as also you can get higher resolution, but only on limited vertical field of view. And on rotating sensors, you might have different configurations of your beams. Uniform, which is basically uniform distribution along the angle. Gradient, which typically is used in automotive lidars and which gives you much denser information in the middle of the field of view of the lidar. And two which are more scenario specific, which are below and above horizon, which will give you basically a half of the vertical field of view from uniform. The beams will be still distributed equally in this below or above horizon field of views, but they will be distributed, as the name indicates, either below horizon from the LiDAR perspective or above horizon from the LiDAR perspective. In non-rotating sensors, number of channels and resolution depends on how the sensor is designed, what is the field of view, and what kind of technology such a sensor use. So it will be very sensor specific, and for details I would advise to check the documentation for the sensor. And why is the LiDAR technology crucial for innovation? On those two videos you see a camera view on the left, a LiDAR view on the right at night, and you can see a difference directly. Camera world is very dependent on the light, ambient light around, and it can be easily underexposed, overexposed, and will not give you much information in difficult conditions, where LiDAR as active sensor will send information, pulses out and receive bounced information back. If this information is missed and is not received, this also can be very well interpreted, so you can even use it in some very specific situations where there is completely bad visibility. Now, making LiDAR even better with advanced 3D perception software. So the question is, LiDARs are great hardware, but can you make it even better? And the answer is, of course. First, using advanced self-diagnostics to detect if the sensor itself, if the hardware itself is, for example, dirty, if someone covered the sensor, and also get some statistics, some information about sensor health itself. Then another part of the software which might advance the usage of the LiDAR is understanding of all scenes, what is happening around, what is the static environment, what is a dynamic object within the static environment. This can be done in LiDAR processing software, or as we like to say, in LiDAR perception software. And of course, noise reduction. And in this case, I'm not talking only about sensor noise, this is one part of noise reduction, but also very important is to ignore or to not trigger alarms based on the data which are not relevant. So for example, if you have surveillance system with LiDAR, you would like to not receive alarms from the vegetation, from the trees, from the bushes, which are basically moving a little bit because of the wind. You want to possibly interpret several frames together from the LiDAR, so basically compare to each other, get more insights. Sometimes custom settings to adjust sensitivity are critical for having system working properly. And of course, ignore point cluster with noisy behaviors. When there is some dust moving around, when there is, let's say, rain or heavy snowfall, and this potentially could be detected by the LiDAR because of, let's say, big snowflakes, it is possible to get it filtered out with usage of proper software. And now the biggest question: how to achieve autonomous excellence? And now I will present 10 use cases where the LiDAR as a technology, as a data provider, will be outstanding compared to the other technologies. The use cases which we as a Flasheye were working through, and we were testing our software and this LiDAR technology versus another technologies. So we can say that in those applications, and for sure much more, LiDAR will be a great addition, or basically will solve the problem which was not solved before. Starting with train station safety, application number 1. And this one you can extend to basically almost any critical infrastructure areas where there are some rules which needs to be followed, and you don't want to have a lot of personnel walking around, watching the cameras, something also pretty automated. In this case, you can look, for example, at power lines safety, platforms, perimeter, and also possible sabotage. And in this case, enhanced autonomy will come with automated safety and also reduce human errors and monitoring tasks. Basically, LiDAR together with perception software will help to monitor those areas in autonomous way and report to the operator or to the person which is responsible for surveillance if some anomaly happens, if some unwanted behaviors will happen. Application number 2, it is we call it border protection, but you can think about any place where you have let's say remote area with a lot of vegetation and something some areas where you want to get early indication that, for example, someone is coming or running around, walking around in the place where no person supposed to be. And in this case, LiDAR technology again can provide much more insights and be much more reliable than other technologies by basically picking up a person even like in between the trees, where not always person needs to be visible for the LiDAR to actually understand that this is a person. Keep track and send warnings, send alarms whenever is necessary. In this case, enhanced autonomy comes again with automated security, automated detection of the threats, and reduce human errors and monitoring tasks. Also, reduce need of physical barriers because you have this digital protection, which if necessary, will send you information that something is happening in that area and give you accurate location where a person, an object, will be visible for the LiDAR. Another use case is PTZ control. Again, this is one of the applications from surveillance, where you can use full potential of 3D LiDAR and, for example, 3D rotating LiDAR, which can cover pretty big area, together with standard PTZ surveillance camera, where LiDAR creates, or LiDAR understands environment, it detects the objects, people, cars, and so on, moving around, and can navigate camera to confirm what is happening, or confirm who is in this area, or what is happening into the detailed level. And in this case, you can think about it that, of course, it can be camera which will navigate through the space on its own, but you cannot trust this kind of scenario, because if you program a PTZ camera to follow specific routine, it will be happening over and over and over, same routine, same movements, and someone who is observing the area might notice that and might recognize it and learn that in this time, with such timing, can go around. When we are using the LiDAR, no matter where the camera is pointing, LiDAR detects 360 degrees and then can navigate the camera. And also, you can consider another scenario where multiple intruders will come from different places. LiDAR will pick them all in its field of view. Then it will navigate the camera from one to another, so you can get this visual confirmation what is happening in the space. Enhance autonomy, automated control of the PTZ cameras, and of course reduce need of operators to monitor the video streams and to control the cameras manually. Application number 4, slightly different from surveillance security applications. This time we are talking about tolling solutions, where you need to know exact dimensions of the vehicles driving on the roads. In this case, LiDAR provides you, as in other cases, but in this case it is very important that LiDAR provides you exact and very precise data of the objects, of the points which it detects, which means in a very accurate way you can create the dimensions, you can calculate dimensions of the, let's say, vehicles. You can recognize what kind of the vehicle is traveling, and also you can get velocity as a bonus of the vehicles which are traveling. And in this case, enhanced autonomy comes with automated control of payments, reduced needs of human errors and monitoring, and also enable remote control. There might be many stations, many tolling stations operated by a single person, which just have a look if all is correctly functioning. Additionally, on the same solution, wrong direction drivers can be detected and some warnings can be sent, which might not only save money but also lives. Moving on, process automation with the three-dimensional LiDAR data. You can optimize already existing processes, which, for example, right now we're using different kind of sensors. With three-dimensional sensors, you might optimize the speed, how the process is running. You can make it much tighter, you can make it much more efficient. And in this case, you can also detect different anomalies. If, for example, something will happen which is not meant to happen, In this case, on this recording, you see wood logs traveling by some special table moving on up to the conveyor belt. But this same scenario can be programmed for the LiDAR to monitor if the wood logs are correctly aligned. If there is some problem with alignment, it can directly stop the process or send warnings to the operator and automate it in that way, which before we would have to install many different sensors, basically covering all possible scenarios. Right now, you have it covered with only one sensor and a little bit of intelligence in the software. And the enhanced autonomy in this case is automated detection of the deviation and automated control of machines to optimize operations and increase production speed. Another application, one can say, from the again from the surveillance part, from security part, is to an identification of unauthorized and intruders. Unauthorized means a person which should not be in the place where it happened to be. And in this case, you can see integration of two completely different technologies. One which is LiDAR, another one which is ultra-wideband tags, which personnel in many industrial places already have. And you can think about it. People which supposed to be there are marked on green in the video below. Person on red, object on red, is not equipped, does not have ultra-wideband tag, so it is unauthorized person in that space. Previously, only using the localization tags, only people which were authorized were detected. But right now, together with LiDAR data, you can actually distinguish which person is authorized and which person is unauthorized, and send proper warnings, alarms to the security. In this case, our enhanced autonomy comes from automated security, also with reduced risk among both staff and unauthorized, and automated communication with both system operators. Moving on to the application number 7. Instruct robots or unmanned vehicles to perform inspections or tasks. And this is application where we are looking slightly from a different perspective than technology happening right now, because currently every robot, every autonomous vehicle is equipped with so many different sensors and relies only on own sensors, where the concept we are proposing here is to use basically global positioning from the LiDAR and exchange this information with the robot itself. So of course, the robot can have own sensors and detect everything in its own field of view, but will get enhanced information about what is happening from the LiDAR system, which is installed in a place which has a fixed installation, and can communicate, can provide information that just behind the corner there is a vehicle coming, so please stop, and can automate different tasks in that way, in fully autonomous way. And as you can see on the recording here, it is a spot robot recorded by our LiDAR system, moving around going towards the entry, and you can have different kinds of scenarios that if the autonomous operation is happening, you can stop personnel to come to this place, or provide information to other autonomous vehicles, how to behave, what to do if such a thing is going on. And in this case, enhanced autonomy comes with the enhance of the performance of the robots and UAVs with information that a unit cannot detect by themselves. So as I said, for example, behind the corner or in the shadow behind the tree. Also automate countermeasures against threats and deviations. Moving on, one of our industrial applications, it is conveyor belt monitoring and safety. In this case, Lidar, again, we are using that every point has its XYZ coordinates in a 3D space. And with proper algorithms, you are getting a lot from just such a data. In this particular case, the Lidar system is monitoring conveyor belt and material which is loaded on the conveyor belt. It can measure material deviations. So for example, if there are, let's say, rocks moving on the conveyor belt and you want to keep the same size of the rocks, the system will notify you when there will be any change in those dimensions, which can indicate some crusher failure or some sieve failure, can indicate some much more serious problems than just changing dimension of the rock, because usually those rocks are exactly the same size, and if this change will happen, means some bigger problem is occurring. And nowadays majority of such applications are done by personnel which tries to remember what was the typical size of this material on such a conveyor belt, which does not have much accuracy. With Lidar and proper software, you can get this information right away whenever this change will occur more than defined percentage which you can accept for this deviation. Also, such a system can provide you information about biggest size, top size of the object traveling on the belt, as well as volumetric flow. So you're getting most of the time those informations are going directly to the operation center, or basically to the automation which drives the conveyor belt, which drives entire facility. And together with that, we can say for free you can get human proximity detection. So when there will be a person approaching the conveyor belt, the machine can either slow down or even stop in case the human will be way too close or will be approaching the machine. So it gives you this extra layer of safety, which was not really present right now. Enhanced autonomy for those cases is automated detection of deviations and automated control of material traceability. Application number 9 is aerial detection of drones and threats. This is something which is happening right now with growth of and availability of drones. Majority of the time the drones are used in a good way, but it happens that from time to time we hear that some airport has been stopped completely due to the drone activity, unauthorized drone activity. And with Lidar systems you can detect drones and you know exactly where they are and can take some preventions towards them. So and it is not only on the airports, basically on any we can say critical infrastructure, if this is communication radio towers, if this is water dams, this kind of installation can help to detect such activities and report accordingly. Moving on to our last application for today, number 10. We call it internally in Flasheye this application load finder, but what it actually is a data from the Lidar aggregated and built up together. So as you can see on the left side of the screen, dump truck, driving underneath the Lidar and the Lidar software, making three-dimensional model of the truck. At the same time, we have a model of the same truck when it was driving in opposite direction when it was empty. And with calculations, with proper calculations, you can get directly volume which is loaded on the truck. And in this particular case, it is in mining environment. So the truck is driving inside the tunnel into the mine empty, outside from the mine filled with material, and on the way without slowing down, without stopping for measuring the weight, without any extremely expensive and difficult infrastructure, you can get volume measurement basically on the fly as it goes. So even before the dump truck will leave the mine, the system, the mine management will know how much volume is removed from the mine. At the same time, it can provide information about the material which is on the truck. If there are huge boulders, if there is nicely distributed material, if the truck is overloaded from the height perspective, if there is a risk to damage some infrastructure in the tunnel, all those informations coming from the Lidar, from just possibility of having XYZ per point, and proper software which can build up those this information together and have it sent to the management system. Summarizing a little bit, you can think about Lidar perception as a building block software where you can pick up different puzzles from the software and use for your own application. So these applications which I mentioned, they were just typical applications, just a couple of applications which we are working with, but much more is possible. And basically, I used to say imagination is the limit, but of course, you have to consider that the Lidar provides you extremely accurate, extremely precise data, which can be used in a different situations. You can create different three-dimensional zones. You can get three-dimensional tracking. You have all those good things like classification, 3D model build-up, volume measurements, PTZ, camera control. So whenever you have some application in your mind and possibly can be covered right away with our perception software. There is a couple of key takeaways which I would like you to take from this webinar today. First, you can start your Lidar journey already today. Our software supports a lot of those applications which I mentioned, and basically we can create new applications on fly by using already existing blocks. Lidar, in the past, it was a difficult technology to implement. Now we are changing that. We are solving the problems which were not really possible to solve before, or were very difficult or very expensive to solve before. And also, Lidar is great on its own, but also it is a good complement to already existing solutions like PTZ cameras, where you can get detection from the Lidar and confirmation from the camera. And with that, I will quickly move towards the questions. I got a couple of questions from the chat. First one, what is the longest range you have experience of? So this range is defined by the hardware, and there is very wide variety of the lidars available on the market. What we are like to say is anything between 0, so basically very close range detection, up to 400 meters from the lidar itself. This is something which we have evaluated, we have tested, but this is technology which changes basically every day. Automotive industry is driving this technology forward, and new sensors are coming, and I already heard about lidar sensors with range of 2 kilometers. So high likely in very soon we will be able to get lidar detecting objects within 2-kilometer range. All right, another question. Can you mention about industrial integrations? What is possible? So right now, out of the box, our system supports data, all the information over MQTT, which is pretty well-known IoT protocol. More regarding the more typical industrial integration is OPC UA. This is something which we are working with many of our customers. We are sending data over OPC UA to already existing platforms they have. If there is need of something very low level, let's say like that, we also can support digital outputs. So basically you create a zone or you create your functionality, and then you trigger digital output on and off, which allows you to integrate LiDAR sensor directly on PLC level, where in like older PLCs where you have basically just digital inputs on and off available. Another question, will the presentation be available after webinar? Yes, we are recording all our webinars, and they will be available on the YouTube, and we will be sending those recordings afterwards as well to all our attendees. So please check your email in a while if you have received. If not, feel free to contact us. And anyway, if you have any idea how to address some already existing problem which you have with LiDAR, feel free to contact us at info@flasheye.se. And with that, I would like to thank you for your attention and hopefully see you soon.